did my research on Trirings and Trifields, which is something that I created in an undergraduate abstract algebra class. You generally learn about groups, rings, and fields, which are structures with 1 and 2 operations. That's where you stop. So my motivation for this research was considering an extension of this to 3 operations. And I classified structures where all 3 operations behaved similarly to addition and multiplication, and all 3 were invertible. And I considered, my first result was finite trifields, which were finite sets that had these 3 operations. And a finite trifield has exactly the size 1 above a Mersenne prime, which gave an equivalent condition to the Mersenne prime projection. And after completely classifying the finite trifields, I moved on to the problem of infinite trifields. And it wasn't necessarily clear that these existed. So for my first result, I was able to prove that a field is the lower field of a trifield, so it matches up with the first 2 operations, if and only if it has well-defined nth roots. So that whenever you take an nth root of something, there is exactly 1 option inside that field to get. And using that, I was able to construct an infinite trifield using an ultra product of finite fields. And after having an infinite trifield, the conclusion of my research for the moment is a prime trifield, which is similarly divided into prime fields, where prime trifield has no non-trivial proper subtrifield. And it is very simple to show that all finite trifields are prime trifields. And in the infinite case, I was able to construct certain examples of infinite prime trifields, but I have not been able to find all of them. And that is one of the things that I'm still researching.